So I've redrawn this and moved it over to give myself a little bit more room. The way that I'm going to draw this is the way that I'm going to recommend that you draw meiosis throughout the course. There are different ways you can draw it. The way we're going to draw it is we're going to show the meiosis 1 division here and then the meiosis 2 division here to give the 4 final products here. We're going to keep it all in a nice line. The reason why I'm recommending that you do it this way is because later on in the course, when we deal with more challenging situations, it's going to be very convenient to have everything in a nice line, as opposed to sort of drawing it in some sort of vertical format to try to keep track of things. So while it's not absolutely necessary for these types of simple crosses, get into the habit of doing things this way, because it'll be much, much simpler to do things this way later on when things get more complicated. So we've got to the point where the chromosomes are replicated and they've synapsed with their homologous partner. Now this cell is ready to undergo the meiosis 1 division. So the meiosis 1 division simply takes one of each homologous chromosome to the poles of the cell. So this is the stage where we're actually going from the 2n state down to the n state. Although it's a little bit interesting because we're down to n, but yet there's 2 copies of each homologous chromosome. So it's kind of like a doubled n, not 2 sets that came from 2 different parents, but now twice over a single copy. And then the M2 or the meiosis 2 division will take that down to individual copies. Now, for any division that we want to say happens for this pair, there's 2 possible divisions that can happen for this pair. 50% of the time we will have this, and 50% of the time we will have the opposite division. So this is a 50-50 probability. Now you might ask, well, the way they're lined up in the cell, doesn't this imply that these ones are always going to go together? No. Chromosomes are very, very flexible. They're lined up at the center of the cell, and it's simply a question of the cytoskeleton from the different poles finding a centromere to attach to, and it's a randomized process. So 50% of the time we're going to have the one segregation pattern, and 50% of the time we're going to have the other segregation pattern. Let's just work our way through this segregation pattern first, where we're simply taking, put my chromosomes back here, where we're just doing it in this simple form. So what this does is it takes the first, or these 2 chromosomes up to this cell. So we have the big A there, and we have a little b there, and now this is actually one cell, because after the chromosomes are pulled to the poles, then cytokinesis will actually split this cell in half. So we'll have that being the one cell, and then the other cell will get the other chromosomes. Now, the meiosis 2 division then takes each of these cells through one more division step. And meiosis 2 is always simply just taking things that are attached at centromeres and dividing them and pulling one copy to each side of the cell. So if you follow this through, you'll end up with a number of different, you'll end up with four different products of meiosis. Maybe I'll just draw all these out first. Okay, and these are all individual cells now, individual haploid cells. So here we'll have big A, that will have big A because these are coming from this particular myocyte, or sorry, from this particular cell. that's gone through the M1 division. So we get the big A and we'll get the little b for both of these. Now down here, we'll get the other possible outcomes. So for this particular meiosis, you can see that we've formed only non-recombinant outputs. Here's our original input, one of the original inputs, big A with little b, and you can see we've formed two products of meiosis that have a big A and a little b. On the other hand, we have little a and big B, and you can see that's the other input. So we've got those. So these are all completely non-recombinant. And what we'll see in the next video, as we start again from here, we'll do the alternative segregation pattern and work that through.